Okay, welcome everyone to High Performance Computing, our practical lecture 01, short introduction to SSH and Unix for those that have not previously used that before. It's the second part of the lecture, and in the first part, we actually looked a little bit more into the SSH, into the secure shell. We tried to understand why public and private key pairs are so essential for this and why SSH is really a key technique really with those keys to access HPC systems today. We did some practical experiments of actually logging in with SSH key pairs to the deep test cluster, but also to the earlier system we have here in Iceland. And of course, it's not a big introduction to SSH. It's rather that basically people need in order to fulfill the requirements of the assignment. So there's more to understand in SSH, and usually that should be part of an operating system course. Equally is true here for the second part. Now I will revisit briefly SSH, of course, to log into the systems, but then show some practical Unix commands, just more or less as a preparatory lecture for the course. For those of you that are Mac users that know that a little bit more than maybe those that are in the Windows environments, or even just iPhones or iPads to study. So in this sense, these systems, what we here as a practical lecture demonstrate, let us come then also to the first one we had, use a deep test cluster, is of course a demonstrator, but it also carries the essence of all other systems you have in HPC. Hence, when we go maybe to, again, the system we have here, the Jülich Supercomputing Center in Germany, is basically one of our close collaboration partner, enabling us really to have a good system already in order to compute the assignments. So we have here a node count of 50 for the cluster module, high single thread performance CPUs. But then the booster module, the modular supercomputing approach, means there's also a booster partition that usually has lots of GPUs. You see here 75. And the reason why we call that test cluster is if you go now to a production machine, like for instance, Jubels, it is a modular supercomputer as well, but this is really a powerhouse horse. I mean, this is something which really is a production machine. And you see here alone, the Jubels cluster module again has over 2,000 something standard compute nodes, right? And many login nodes. So here we talk about around 120,000 CPU cores available in alone the cluster module. Also important for the course, and we will revisit this in later lectures, the interconnect that I was alluding to in the prologue, right? Marking a bit the difference between HPC and HTC, if you want, is really the Mellanox InfiniBand demonstrating you, for instance, a very good interconnect between the nodes, making it possible to use this machine then for prediction, numerical weather prediction, and these kind of elements. Also, this will be later explained in the course, but it also shows you that the Unix and SSH is the similar elements that you also need in order to go to the production machines. That's why we're telling this. Also, if you go now to all the your HPC JU machines that we have explored in the first part, this is something where Unix skills usually, and also SSH, is a modus operandi. Just briefly here, the Jubels booster module, also a production machine in terms of scale. We have here over 900 compute nodes. If you remember, of course, this was really oriented towards GPU processing, scaling out. So maybe not, let's say, moderate single thread performance on CPUs, but for us, it's really important to have 4 NVIDIA GPUs per node. And you see that here, that's already the next generation with A100, not the ones that we have in D with V100. So hence, this is quite interesting. Chances are also that, and I just believe that here, that of course you will see the Jupyter system that will come. You see that a little bit essentially as the exascale system for Europe as an arrival. It will soon be available in Jülich, and chances are it will even appear during our course. So that's exciting times for us. Let's come back a little bit to this practical lecture here. Of course, Elia now is not far away from the modus operandi. It's a smaller system. It's a university system, basically used for teaching, but it has also, let's say, good NVIDIA GPUs. You see the pair line here with A100 cards and the GPU nodes. Of course, it's a much smaller system. It's not a European supercomputer, if you want, rather a university system for doing research here. And of course, researchers and engineers can do their baby steps on these systems here like earlier and then apply for your HPC-JU computing time and have also the possibility to get to European large supercomputers and then can scale up their problems very high. Still, coming back to the practical idea of the lecture, many of the things I say will be also repeated in some of the other coming lectures with much more detail. So what is a GPU? You don't know really for sure yet. It's an ecosystem we'll talk about and we'll differentiate it also from multi-core systems. So hopefully in the course we'll go earlier, so that should be not a problem to also touch metal, as we say, so really have a rack explored, how that looks like, and also we plan to maybe have another visit like we did in the cloud course to the Borealis data center or another data center in Iceland. So, but let's come a little bit more to the practicality. So we want to go back to our MOAB X-term. So this is the MOAB X-term I was alluding to. Again, I will not do this now slowly, but rather quick, because we have learned this in the first part. We need host name. We need a specific username that was given to me, in my case, Riedel1, and we have to pick a certain private key in order to get the access, which is usually then protected from, let's say, a password. In my case, I have used that before. So in this case, I don't need to put this password in again, but I have to show the private key that I have this. Now we are in deep. So what we want to do is now to understand, are we really remotely? And there are different ways how you do it. Host name, for instance, -f is one opportunity to see, okay, it's already another name as probably on your laptop command line or on your user on a laptop. But, the host name is already giving us an indicator, but it's not full yet. So there's an opportunity with host name -a to show you all information where this is mapped to. And here you see clearly we have here a host name that is somewhere in the jülich.de domain. KFA jülich.de means an older name, but that doesn't bother us. It still shows us a little bit that it's quite remote. Additionally, of course, we have the SSH, and you remember you can also SSH with command line into with having your username at this host name, and then you present the key and can also access it. So we are also sometimes interested, who am I? So just to understand, okay, now I'm really Riedel1. So in other words, also here, my laptop identity is not there anymore. It's of course that identity that I have there basically on that machine. So simple Unix commands really, and this is a key message also briefly what I put you on the slides, right? Some of them of course are, let's say, also to Elia here, and we can do the same exercise later on. I will do the same setup briefly going to Elia, for instance. But what I do here is actually simple Unix commands that you can also execute on any other HPC system. So when we continue to think about what else is there, who am I did already. Another practical one is essentially then the clear. That is quite useful. So when you have the screen, let's say, working on it, and there's a different simple commands that we will look in, and you have the whole full whatever. We have the different work with directories and change them. Maybe have a look at the old directory path that we have here, and then we see different elements. Or we have here the idea to really think about how to clear the screen, and then with clear you get the overview again. It's another interesting kind of idea how you can use normally Unix commands. Then of course we can think about the mkdir folder command. So we can basically go back here. This is also what I documented. So in our case, I already did this. Basically, then that means we can go into this one, for instance, and look that there's already a test file that we're going to generate, but we can also remove this test file. So I will do this later with rm. And with mkdir, we could do now, let's say, another element that we have inside the course. Now, the interesting thing is that we are already in the HPC course Spring 2025 directory. So when we here do now, again, let's say double this and say, well, Spring and then 2025, then I make another directory in the directory. So still I can do this. There's no problem in this, but ls-l, you always see what's happening. But you also want to, basically remove this directory, perhaps, and remove files, which you can do in this RM. And here, maybe, for instance, star is something where you be careful, cannot remove a directory. That's a good protection in a way. So remove means you basically do remove of all types of files. So when I say touch test file, touch means it creates a test file. And when I now do rm star, then I can remove this and file, but not the directory. And I think that is very good to understand. If you do this, be careful, especially in your home directory, of course. That is not good. So there's a specific command which is even more powerful, which we often use, something like this. You need -rf. These command line, let's say Unix command, would have also different parameters. And now you see suddenly we cleaned up the mess we created with a directory in a directory, for instance. It's clear, and we could even directory remove, right, with this command rm-rf star. It is very powerful. So there are man pages available for you during the assignments and so on, where you can learn essentially about these different parameters, a sort of small help. Of course, those of you who are more inclined to the internet, feel free that, of course, you also can go and essentially browse in Google and so on, and you will find also similar pages explaining you what happens. Having done this, having created a directory, removed files, so these are a couple of things. Not all of that is maybe perfectly documented now here because it's a practical lecture, but very similar things should be essentially now here in this particular one, the CD one, and so on. Yeah, another interesting thing is, maybe apart from this, the and RL, I will come back to this in here, is of course now think about that we want to maybe have the working directory where we're in. Now you see when I list here this parts that we have in this particular directory, we want to know where exactly this is. So we can do something called print working directory, where I see exactly here on deep, I'm in this directory for users under my, let's say, user ID for deep. So, and now back to the slides. Yeah, essentially everything I have demonstrated, you have in one way or another here and there on the slides. And of course, here and there, the man pages will also help you forward. And having Unix skills is definitely something, I think, which every computer scientist had to have a little bit at least, which we also teach in the operating system course, for instance, but there are also many courses outside in the field on the web. So there's one thing I also wanted to show you as part of this before we go to Elia and repeat some of the elements, which is a little bit more towards also the environmental tools we discussed. So we said there's lots of hardware. You see this nicely in our pictures here. There are racks, there are CPUs, there's storage, there's interconnects and so on. But of course, there's also the point that we need the right system environment, really. And one of the crucial things really is the module environment. Another one is scheduling, because it's a multi-user environment. And that's why scheduling will be a practical lecture after we have clarified in our normal lecture 1 or conceptual lecture 1 what HPC really is. Then we will go to more and more environmental tools that are basically there. But today we start a little bit here with the system module environment. And this is something which is also available on a wide variety of HPC systems around the world. It's almost a de facto standard. There are rarely packages handled differently. But the module environment is something where you have essentially all different compilers that you maybe need if you program in C, C++, Fortran, etc. Normally, Java is not the world of supercomputers, so you will find rarely Java and interpreter-based Java somewhere as an application in HPC. Rather, MPI for Pi, maybe Python would be something used, particularly also using HPC with AI. There, of course, Python is still modus operandi. But coming back to the compilers, there are lots of them with different, let's say, capabilities. One of it is also to support then the message passing interface implementation, which will be also coming as one of the next lectures. If you remember, programming in parallel with MPI and then later with OpenMP will be also in lecture 2 and 3 and so on. Hence, we will have here the right environment to have on these HPC systems to use codes like you see here, a C code called ping pong we will analyze later in the course and compile it and to make an executable that can actually run on a supercomputer. Hence, there's lots of software infrastructure, as we call, around the HPC systems as well. It's not just hardware. There are lots of different compilers, yes, and let's say message passing libraries like MPI and so on, but also scientific and engineering specific and application specific libraries are there. If it's for molecular dynamics or if it's a lava flow simulations based on mechanistic modeling, there are different packages that you can actually load, and many of these will have also, for instance, also in the AI environment, and I will come to a demo shortly, they will have also dependencies. And the dependencies are usually lower level libraries, like for instance, if you use NVIDIA GPUs, you have often, let's say, CUDA requirements in packages, because this is the basically interface or the programming language, really how GPUs are programmed from NVIDIA. And when you have AMD GPUs, then you have, of course, another toolkit. So long story short, you come to a situation that you have a multi-user system, and this multi-users is loaded. All of these different users have almost different requirements. Of course, there's an AI team, maybe with 5 or 6 people having exactly the same requirement, PyTorch or TensorFlow, Horovod, whatever. However, if you look on the overall usage of HPC systems, which could be in the cases we discussed with Jülich, in the hundreds, right, of different user groups, there are different applications that have to be supported, and with this, many different libraries. And how this is managed in a proper way is basically the module environment tool. And this really simplifies a lot of things. So we will look at this also when we use, for instance, the compilers in a practical fashion down the road. But I just introduce it here a little bit and demo it now when we go back to our deep environment. So I clear here again, and one of the things what you could do in the beginning is really to get an overview when you log into a system like deep and do something like this, module avail. So this already shows you quite something. So this is the package here that you have now for many, many different applications, from Eigen, your solver, you have HDF5, Parallel IO libraries here, for instance, and also how to view them. You have, if you go down the road, Julia is one of a specific programming language. Jupyter Lab is a sort of interactive access to HPC systems. We'll clarify this when we come to the AI in the course later. You have lots of different tools like MATLAB, for instance, that some of you know maybe from the standard scientific computing. They have also parallel toolboxes, so you can work with MATLAB also in parallel. And you go on and go on, you will find more and more libraries that some users will use in their, let's say, daily work with HPC systems. And you see here also one particular one, we will also come later back into the course. PyTorch, for instance, is a very popular tool for AI, for artificial intelligence. Notably, deep learning models is something what you program usually in PyTorch, or you have also as another, package, the TensorFlow, basically available that you use, and then also with Horovod going there. Now, this are already advanced libraries, and the requirements there is, of course, having also standard libraries. And standard libraries could mean something like, for instance, the usual Python that you would to have, right? So it's not that this is just higher level libraries. You see also here lower level, the standard Python distribution, or the standard R, it's basically also for data scientists, a very known tool, are available in these modules. You also realize they're coming with different versions, right? And we don't have time to go into the complete setup of Deep. That will take a whole lecture to go and, to go through all of the different packages. Also NetCDF is here actually something for parallel file formats, but also you have SkyKit Learn here as something that many of the data scientists will be again familiar with. They have lots of serial implementations of AI, meaning machine learning models, and also basically popular data science techniques that you can use. So all in all, that is very nice for us as users, because the essentially the administrators of these machines have prepared all of these libraries. They compiled the libraries against the right, let's say, lower level libraries. You see this often here when the CUDA is basically coming to the situation here, that this is linked to this particular CUDA here. Nickel is a lower level network library from NVIDIA with a specific version of CUDA compiled and ready for us to use, which then gives the ingredient for using NVIDIA GPUs on a higher level than with something, for instance, that we have in PyTorch or so. There are lots of details on the module environment, and of course, the idea is not that we have now, go through this in the complete detail. Just that you know this command, and if you go now to some other HPC system, you will see it has a similar command available for this to use. And then when you want to basically understand and load one, you would also have then, the ability of module spider elements. So if you would say we module spider, for instance, is PyTorch, then we want to understand what is it all about with PyTorch, what is the information about it, having also, let's say, dependencies. You see that here very nicely. I mean, first of all, we know it's a neural network library, but we'll come to this later in the course. But also, of course, it's related to several different pieces, like Python, for instance, is built for GPUs. It's a very important part that deep learning is essentially just possible with GPUs in HPC machines. And it's Python, so hence the name. And you will see now different stages and different, let's say, elements that you will need to load these modules if you want to load PyTorch. And the reason is that in the stages you have here, many of the basic libraries that PyTorch needs are already, let's say, pre-installed. So we module spider maybe on different of these different libraries in order to get a better view what actually is all inside this. And then we can basically go and see there more. The key message is to take away that, of course, you can also not only use this, you can also talk to administrators, right, and say, could you please install different elements of it, and then also have a look of if they can, when you have maybe a research group of 10 people or 10 students doing similar things, they can maybe prepare that better for multi-user usage of having this once installed, so that everybody of you have to install that a little bit on your own. And with this, chances are that you really can help your team, because then they just have to do module load and can do this easily. So yeah, we module load with a command. We can also module unload. This slide example I had, I think I have to look at it, was we can load, for instance, a Python package, which we have here, Python something that gives me also the opportunity to introduce a tab. So if you do the tab under module load Python maybe, and in general in Unix, it will give you options what you can do. And I will demonstrate this maybe with the directory as well. With the tab now, you see the different options you would have, how to continue. So we can run Python, the very specific version, which is sometimes required, like this one here, for instance, in order to support, let's say, a very specific tool set that is, against Python 3. But of course, older codes might be requiring Python 2 and older versions. So there might be also older versions installed. So this is a really nice helper tool. And just to demonstrate the tab again, if we say now we had our HPC course, right? directory. So we say, what was HPC course, but what was it called again? I do tab, a couple of times tab here. And then all the options come suddenly, right? You even go back when the HPC course was in fall 2019, because this is all the directories that you have here. And then we can, with tab, continue all the time in order to go in. This is a quite nice thing and can help you a little bit, not only in this module environment, but also here in the idea of browsing through directories, opening files, etc. This is all something useful in this manner. Oops, of course, you have to be precise with these things. Yeah, what else? This is a bit about the rights. You see here now, maybe the elements we should also discuss is not only when it was created, obviously today at some point in time, but we have also the username that is actually creating it. And then also you have an indicator that this is a directory here with D in front. And then the basically, is it a read, write, or executable rights to do so in this particular directory? And this is important when you have a C code, you compile it, for instance, then you need the X to really execute something. And we will make the case then when we have really something to execute in part of the compilers. But this is essentially the information you see here, also the size, obviously, of the different files and directories. And with this, let's go a little bit back to the slides. Having now understood perhaps a little bit the module environment again, this is not completely obvious to you. It's clear how that materializes when we will go and really use it, for instance, with a C compiler, also where we start from perhaps in one of the MPI lectures, where we then have our first C program from MPI compiled and so forth. There you need already a specific type of compiler and things like that. Good, but let us now move a little bit further, coming a bit to the idea of using VI. That is also an important tool, which is a bit tricky to use for some, but it has also, of course, the possibility to be used on many of these different systems. It's really the most basic, in a way, editor you can find. Of course, in the course, you also find to use Nano. I think many students use that in my course, but also Emacs. Of course, some of you know that, especially those that are in the Unix territory more. There are different editors of files, but the VI has the advantage a little bit in the sense of saying it's always, almost always this tool, that is basically on the HPC machine available. So if you go to 2025, maybe to our thing, we can do something. As I said to you, we can create a file, touch, and say test file. And when you look at it, it has 0 in size, obviously, because we just created a file which is empty, right? But we want to fill it. And let's say we have VI test file. And we'll basically say then, welcome to our HPC course, spring 2025. Welcome in Iceland, something like this. Now we have this insert command, and this is now the interesting thing. So you put exit or escape here really, and then colon, W, Q, and exclamation mark, saying like we want to write and then quit. Right, so hence the commands are a little bit, when you do the man page with VI, that you have these two modes really. One is an editing mode, an inserting mode. There's also a appending mode. If you go again to this file, and here we just say A, right? Just say A, then we are already in the appending and inserting again. Welcome. And then I do escape and then colon again. That's an important part to mark now the kind of commands that should be done with the file, and then write and quit and so on. So using this a couple of times will of course help you also to get familiar with. You see now by filling it, we already have a couple of bytes here, and also see who can actually read and write in it, which is the owner basically, and then the group. Users can be in groups, which is not totally obvious. So it is basically something which has to be configured, of course, with people that are administrators. And then to the whole world is again also one write. Good. With this, you have seen on deep a lot now. I can go on and go on with different Unix commands, but that's also not my job because we want to understand more on HPC. But before we, let's say, finish for today, I just wanted to make a quick walkthrough again and finish here with our deep system. Remember, with our host name -A, all what I demonstrated to you was more or less on the deep machine, right? And now the idea is, what can we do on Elia? Right? For this, we exit here and want to go, of course, with an SSH section elements. I just get here, but it will not be automatically saved. That's not a problem. We don't need that. So we said elia.how.is. And you remember my username. If you come now back to the beginning here, where we said everything I just demonstrated on deep, we can actually also do on Elia. And my name on Elia was actually Morris at Elia, if you remember. So not Riedel1, which is an important thing. So a different username. And if I would put Riedel1 here, it would not work. Equally, I need, of course, my private key here to actually get into contact of this. And we'll make a connection with SSH to Elia. Now, the question is if they are happy with our password for the key store, because it was quite a while ago where I have used Elia now. Could be that they force us to re-enter the key password. If you remember, Elia was always a little bit, let's say, longer. They are fine. We don't have to provide the password right now. So obviously, more or less, you see already we are on Elia, right? The welcome screen looks different, as I was also demonstrating you in the first part of the course. But now we want to go into some of the aspects for Unix so that you notice that actually we are on a different HPC system now. Now we are on this system here in Iceland, so not anymore in this deep system in Jülich in Germany. We are now essentially here in the Elia, and you would have lots of documentation here if you want, the overview of the partitions, and also here Jotun is something we use for teaching, for instance, that will come back to you in one of the assignments when we use it. But essentially, that's important to understand that the Unix commands we did, like for instance, which is now crucial for us, the hostname -A, for instance, shows you very clearly we are not anymore on the host of deep.kfr-jülich.de or so in the German domain. We are now in Iceland. So this is important for us. So hence, all the commands you learned are basically still working, ls-al. Right now you see there's a directory HPC course spring 2024. And we are in a complete different home directory. You see here, I'm actually mapped to the Jotun area because we are in our teaching lectures here, and Jotun is our teaching area on this. And this is our working directory that works. We can also create now, which makes sense, basically a directory here with the usage of mkdir to create this HPC course spring 2025 directory. We can also remove that again and use this trick. If you remember, that's important to realize with this element again with the mouse, and then maybe just change the last one so you can be a little bit more faster in several elements. Equally, the idea of this tab works. So if you say, this was a HPC, let's see about you. You're moving through directories like now. You're somewhere. Okay, I'm there in my home directory. So there was some HPC course, but I don't know what was it exactly called. You can say something like HPC and tap it. And you see that's the most common option. That was not in deep because we had a fall actually. Here we just have 2 spring courses. And when I do in continue tab, it will give me the 2 options I have. And basically, of course, we would be now interested in the 2025 one. Right. So with this, we have the same functionality on the Unix, as I said, also when we would create files, like for instance, touch test file. Here, you would see equally like deep, it's a 0 file. We can remove the test file. Oops, sorry for this. Test, that's why tab usage is sometimes quite useful. You say test and tab and have the right name. I just had a typo. And equally, we have here also this powerful, if you say make directory test here in this, HPC course, And the protection, if you now want to remove the test, is a directory that will not work because there may be many files in it. Hence, you have to do a strong command. If you, for instance, have test file 2, have a kind of thing where you can say rm, remove everything. It will remove the file, but not the directory, which is sort of a nice protection. And if you, oops, a bit too fast now, sorry. But if you want to to remove everything in one directory, you have to do rm-rf star, but then please go carefully with this command, because you could also crush your home directory with it. So in a way, that's all, I guess, what we had roughly in the slides on deep for the normal Unix. Host name we have tackled. Of course, who am I forgot a little bit. That's good to understand. But you, I think, could also understand now already what that would be. Who am I would be Morris, my username, which is essentially already incorporated here. But of course, still is also realized, as a Unix command to understand what is a concrete login you used here. For more information also on software, hardware on these, it is basically all written here in our wiki page in Iceland. However, as you will also know, and I think that's what I also want to finally demonstrate a little bit before we come to a close, we have now clear, we have directories, all the essential commands you need to get going. But I also wanted to bring quickly to you the idea that this module environment that we had now nicely on the other side, basically on the deep system, is also, of course, something, if we clear here maybe a bit module avail, that we would have here on this particular HPC machine as well. And the story is basically the same. So obviously, this is a university cluster. It has probably less systems, software installed, firstly because it's a relatively smaller cluster, not used by so many applications, maybe not hundreds and hundreds of users, but rather maybe 100 users or so and students, which is a teaching environment, which is also sometimes really a difference between the production systems and the teaching or prototype systems. Again, if you think about Jülich, remember, Deep was sort of a prototype system. So even there's not so many applications on. If you would move now to Juvels, right, that was a big system here with the configurations of thousands and thousands of CPUs and also thousands of GPUs. We had here the booster with 3,700 GPUs roughly. So this is a completely different story. And there you have also container technology. You have, different big, let's say, application module systems available for almost all the application users that use the system. Hence, and beyond, of course, if there are new people coming to these systems, chances are that the tools are already installed on this machine. So hence, this is a production system, but Elia is basically just a teaching cluster and as such cannot be so strong. However, it has some of the interesting tools that we're going to use, like the GCC compilers, for instance, for C. It has also several Python versions, and here, of course, the idea is the same: module load, a specific Python that you can have here. Or you want to understand, if I want to have R, so statistical computing with R is an open source project, which many people in data science, for instance, also in bioinformatics use often. So if you want to understand, what is the situation with this R, then basically let's have a look with module spider. So even this command is also there working, telling you it's a free software environment for statistical computing and graphic statistics, of course. So free. And it has several extensions apparently already installed, which is also for us very good. And the interesting thing is this can be loaded directly. So it's not dependent on Python because R is, let's say, its own language, and we don't have to compile it or something. So it's a real ready to run software, whereas of course Python is just basically then the Python interpreter and everything of the environment. And then you have to still use your your application in question. You have also interesting aspects. We come to MPI. You see here's MPI 4Pi already installed. That also gives us the insight that, some packages are really very specific while others are really more, let's say, general libraries, a general compiler maybe here in different versions. CUDA was alluding to the different, remember, versions of how to use an NVIDIA graphic card. Hence, when there's CUDA installed on such a system, we already can understand, there are NVIDIA GPUs. And if you go now to the configuration of our system here, you see basically with the partitions we have and the hardware, that of course the NVIDIA GPUs will be there available to you. And you see here we have, for instance, I think I put it also on the slide, but here it's the NVIDIA A100 Tensor Core that is available. And you need these different libraries to use these A100 card, for instance, in this particular partition. So hence, for Elia, I didn't provide all the slides. I think that's clear because in a way, this is almost the same. So it would be not adding too much insights to really do more on this. So in this sense, we would say we have been now on Elia. Remember, again, we could test this with the source name -a, that we're really there, and I'm Morris there. And that's all what we want to do with Elia in the moment. Here, the basic on Unix, you see that this is working on deep and on essentially the Unix system. But my key message to take away at the end would be now thinking about all the supercomputers that your HPC joint undertaking is running. If you maybe explore this a little bit, if you have a bit of time, you will see lots of different systems with different hardware, very heterogeneous. Lumi, for instance, doesn't have any GPU graphic cards, right? So that is maybe interesting for you to understand. They are basically AMD Instinct GPU cards. So another vendor means another software stack. There's no CUDA and so on. This would mean way too long to demonstrate this all, but this would have an effect on your module environment. However, the way how to load the modules, how to see which modules are available, to spider them, to get information out of it, as well as SSH into that system, and using these, let's say, Unix commands I was demonstrating today, is similar in all of these systems, right? Of course, the specific application libraries are different, or the vendor libraries are different, but still, and of course also the partitions, what we will learn later in scheduling and so on. But this hopefully has shown you now some basic skill sets that when you would have, for instance, also access on these systems, which you can apply to for getting computational time, you would be able to make your first baby steps on these systems in order to get not lost in the Unix environment. So I hope it was useful for those that have not experienced Unix before. In this sense, let's turn back to the slides. And that's all also I wanted to leave here on the table for you as part of this practical lecture. And we will continue with lecture 1, really with a bigger overview, a more detailed overview, if you want, on HPC in the next lecture. So talk to you then.